Hello students, you are most welcome here in my YouTube channel Red Atom Learning Chemistry. See what this is. This is your coffee. You know, coffee is known for aroma. Aroma means smell and is related to volatility. If something is volatile, then only you can smell it, then only you can come to know about its aroma. So in this video, we will be talking about aromatic, anti-aromatic and non-aromatic compounds. In my last class, I discussed about theory related to aromatic, anti-aromatic and non-aromatic compounds. This topic comes under general organic chemistry. See, as I said, aromatic. What aromatic compounds are? Aromatic compounds are those compounds which follow Hückel's rule. What Hückel's rule is? Hückel's rule is pi electrons, number of pi electrons is equal to 4n plus 2, as I discussed there in my previous slide. First condition. What second condition is? Conjugation. Conjugation or alternation must be there, then only a compound can be aromatic. And third is planarity. Compounds must be planar in nature, that is carbon must be sp2 hybridized, then only can be aromatic. The same thing you will apply here for anti-aromatic compounds also. First, Hückel's rule. Here Hückel's rule is number of pi electrons is equal to 4n. And then second, conjugation must be there, and then the third, planarity must be there. And if any of these three conditions are not followed, then such compounds are called non-aromatic compounds. This we have already discussed there in our previous video. So now we will discuss in this video about the examples. See, this is cyclopropene. What this compound is? Cyclopropene. Suppose this carbon is 1, this is second, and this is third. This first carbon is having double bond and single bond. The second carbon is having double bond and single bond. What about this third carbon? This third carbon is having no conjugation, no pi bond is there. Since here there is no conjugation, so this can't be aromatic or this can't be anti-aromatic. This will be non-aromatic. See here how many pi bonds are there? One pi bond is there, and for one pi bond, 2 pi electrons will be there. So n will be equal to 0. So 4 into 0 plus 2. 4 into 0 plus 2 is equal to 2. 4 into 0 will be 0 plus 2 will be 2. So 2 will be equal to 2. That is 4n plus 2 is equal to number of pi electrons. So Hückel's rule is followed. Hückel's rule is followed, but since conjugation is not there, so it's not aromatic. It will be non-aromatic. Now see, next example here, this pi bond is there and free electron is there. So conjugation is there. Here conjugation is there, alternation is there. Now see, what is the name of this radical? Cyclopropenyl radical. What is the name of this radical? Cyclopropenyl radical. Here these are 2 pi electrons and this is one free electron. So 3 pi electrons are there. but here there is no question of Hückel's rule followed, so this can't be aromatic. It is not aromatic and will be unstable. It is not aromatic and will be unstable. Here conjugation is there, but Hückel's rule is not followed. What Hückel's rule is? Number of pi electrons. What Hückel's rule is? Number of pi electrons is equal to 4n plus 2. Here number of pi electrons are what? 3. So, and n is equal to, pi electrons are less than 6, so n will be equal to 0. So 4 into 0 plus 2, 4 into 0 will be 0 plus 2 will be 2. So 3 can't be equal to 2. So that means Hückel's rule is not followed. And like this, anti-aromatic compounds Hückel's rules are also not followed here. So this will be not aromatic and this will be unstable in nature. Now see, in next example, again here 2 pi electrons are there and one negative charge is there. So here conjugation is there. Now see, we will check the Hückel's rule whether it is followed here or not. What is the name of this ion? Cyclopropanyl anion. And here these 2 pi electrons and these 2 pi electrons negative charge, so total 4 pi electrons. So number of pi electrons is equal to 4n. Here number of pi electrons are 4 in number, so n will be 1. So 4 into 1, that is 4, and pi electrons are also 4. So 4 will be equal to 4. What this Hückel's rule is? This Hückel's rule is for anti-aromatic compounds, that is number of pi electrons is equal to 4n. So this is anti-aromatic in nature. Hückel's rule is followed. Conjugation is there. Planarity is there. That is sp2 hybridization is there. Now see there in next example, this is cyclopropenium salt. Cyclopropenium salt, this is positive charge. Here conjugation is there, pi electrons and then positive charge. Since here conjugation is there, and now see here number of pi electrons is equal to 4n plus 2. How many pi electrons are there? 2 pi electrons are there. So 4 into 0. Whenever number of pi electrons are less than 6, then n value will be 0. So 4n plus 2, that is 4 into 0 plus 2. 4 into 0 will be 0. 0 plus 2 will be 2. So 2 is equal to 2. So here Hückel's rule are followed. Conjugation is there. sp2 hybridization it is showing, that is planarity, so it will be aromatic in nature. This will be unusually stable, 20 kilocalorie per mole more than the allyl cation. This will be stable. So that's the point. Now see here we are comparing all the three, plus, minus, free electron and lone pair. In all the four, conjugation is there. This is pi positive charge conjugation. This is pi negative charge conjugation. This is pi free electron conjugation. This is pi lone pair conjugation or alternation. All are having conjugation. Since all are having conjugation, so will be stable. Here see pi bond is there, but here there is no positive charge, negative charge or free electron or lone pair, so there is no conjugation. There is no conjugation, it won't be stable. Now see, this is cyclobutadiene, pi bond and pi bond. 1, 2, 3, 4. First carbon is having double bond, pi bond, and third is also having pi bond. So this is 1,3 conjugation. What is its name? Cyclobutadiene. How many pi electrons are there? Number of pi electrons is equal to 4n plus 2 or 4n. So 4n plus 2 won't be followed here. 4n will be followed. How many pi electrons are there? 4. And since pi electrons are 4, so n value will be 1. So 4 into 1 will be 1. So 4 is equal to 4. That is, it is anti-aromatic. It is non-benzenoid aromatic compound. And this is anti-aromatic as it is said. Now see, this is cyclopenta. 1, 2, 3, 4, 5. 5 carbons are there, so penta. Dienyl, 2 double bonds are there. Cyclopenta dienyl radical. It is having 5 pi electrons. Odd number of electrons are there, so there is no question of aromatic or anti-aromatic. It will be non-aromatic in nature only. Conjugation is there, alternation is there, planarity is there, sp2 hybridization is there, but since Hückel's rule, neither in terms of aromatic nor in terms of anti-aromatic will be followed, so this will neither be aromatic nor be anti-aromatic, it will be non-aromatic. See here, conjugation is not followed. This carbon is sp2, this carbon is sp2, this is sp2, this is sp2. What about this carbon? This carbon will be sp3 hybridized. So planarity is not there. All carbons are not sp2 hybridized. So it won't be aromatic. It won't be aromatic. It will be non-aromatic. It is cyclopentadiene. Pi electrons are 4. And since pi electrons are less than 6, so n will be 0. So 4 is equal to 4 into 0 and then plus 2. 4 into 0 will be 4. Sorry, 4 into 0 will be 0. 0 plus 2 will be 2. So 2 can't be equal to 4. That is why we have written Hückel's rule here is not followed. So that is why it is neither aromatic nor anti-aromatic. It will be non-aromatic. Now see here what this is. This is cyclopentadienyl cation. Here conjugation is there. How many pi electrons are there? 4 pi electrons are there. So 4 into 1. Why 1? Because number of pi electrons are 4. So when number of pi electrons are 4, according to Hückel's rule for anti-aromatic compound, n will be 1. So 4 will be equal to 4. So it is anti-aromatic compound. Now see, the next one is cycloheptatrienyl cation. Cycloheptatrienyl cation. That is tropylium ion. What is its formula? C7H7 plus. It is also known as atropine. Here this is 2, 2, 2. So total 6 pi electrons are there. So 4n plus 2, number of pi electrons is equal to 4n plus 2. Here how many pi electrons are there? 6. Since number of pi electrons are 6, so n will be equal to 1. So 4 into 1 plus 2, that is 4 ones are 4 plus 2 6. So 6 equal to 6, that is it is it is aromatic having sextate structure. It is planar in shape, conjugation is there, so it will be stable. It will be stable. Energy will be 128.50. So this is cycloheptatrienyl cation, that is tropylium ion, or you can say atropine, which is a medicine, which is used as medicine. See here what this is. Cyclooctatetraene. Here hybridization is sp2. That means planarity is there. That means planarity is there. Here planarity is there, conjugation is there, Hückel's rule sorry, is also followed, but it seems planarity is there, but its shape is not planar, it is tub shaped. Its shape will be like this, and tub is not planar, it is three-dimensional, it is not two-dimensional. Since its shape is tub shaped, not planar shaped, so it won't be aromatic or anti-aromatic, it will be non-aromatic, sorry. This is the order of aromatic compounds stability. Aromatic compounds are most stable and anti-aromatic compounds are least stable.